Hello and welcome to Higher Maths Integration Lesson 1. What on earth is integration? Integration is a way of undoing differentiation. Why do we integrate? Well, in Higher Maths, the reason why we would normally integrate is to find the area underneath the curve between a curve and the x-axis, which we will look at more later on. But just now we're just going to find out how to integrate before we use it to find the area underneath some curves in a few lessons' time. So when we differentiate, we bring the power, we multiply by the power and then reduce the power by 1. So to undo that, we're going to add 1 to the power and then divide by the new power. So if I am integrating x squared, which is undoing the differentiation of something to get x squared, I would, first of all, we need to show that we are integrating. So we use this integration sign, okay, which is essentially an elongated S, I suppose, looking at that. So that's not just a straight line. So that's the integration sign. And we must also write dx to show that we're integrating the x's, okay? So the integral of x squared dx, so we add 1 to the power, so 2 plus 1 is 3, and then divide by the new power, which is 3, so it'll be x cubed over 3. Note over here, x cubed over 3, that is exactly the same as 1/3 of x cubed. 1/3 of something is the same as something divided by 3, as you all know. So there's two separate ways of writing that. There isn't a preferred way. Either one is absolutely fine. Now, what is this plus c about? Well, if I differentiate x cubed over 3, I get x squared. Okay, so I've undone that. Okay, but also, if I differentiate x cubed over 3 plus 7, I get x squared. If I differentiate x cubed over 3 minus 19, I get x squared. Because if we differentiate a number term, we get 0. So I know that this will form part of the answer, but we need this plus c on to show that it might be plus 5, plus 19, minus 36, plus 48 pi. Could be any of those or any others. Okay, so we just need to write this plus c. Let's have a look at number 2. So every single time we're integrating without limits, you've not seen what limits are yet, but basically we can do it with limits as well, which we'll do later on. But if we've just got the integral sign on its own with x squared dx or a function of x dx, we need to write the plus c. So question 2 here, x to the power negative 3 dx, the integral of x to the power negative 3 dx, add 1 to the power, divide by the new power, and then plus c, the constant of integration. We shouldn't have a negative sign on the bottom of a fraction, so it's essentially negative x to the negative 2 all over 2 plus c. Again, guys, remember that plus c needs to be there. Could have plus 5. If we differentiate this, we'll get back to x to the negative 3. If this was plus 5 or plus 19 or minus 47. Question 3, exactly the same idea. Add 1 to the power, divide by the new power, and then add our constant of integration, add on the plus c. So I'm dividing by 9/4. That's the same as multiplying by 4/9. So it'll be 4x to the 9/4 over 9 plus c. So the integration symbol must be used with dx in the examples above to indicate that we are integrating with respect to x. We're integrating the x's. The constant of integration is included to represent any constant term in the original expression, since this would have been zeroed by differentiation. Again, if this was plus 5 or plus 15, if we differentiate to get back to this, it will go to 0. And these are called indefinite integrals. Again, we look at definite integrals later on. Let's look at a few more. So that's just saying exactly what I said. If we differentiate this, we'll get x squared. So if we have a number at the front, so for example 6x cubed, we do exactly the same. Add 1 to the power, divide by the new power, add on the constant of integration. 6/4 is 3/2. And I will do the other few questions in a second video because I'm running out of time in this video, guys. Okay, so I'll do 5, 6, and 7 in a second video.